All right. So once again, Fire and Fire History Working Group kickoff meeting. I'll just give a brief introduction to the North Atlantic Fire Science Exchange on John's next slide. We are one of the several fire science exchanges from across the country, and we try to catalyze collaboration between fire scientists and managers to create a safe and resilient North Atlantic landscape. Many of you are familiar with the area that we are focused in, and several people are zooming in from outside of this area, but we really appreciate your interest in fire and fire history rooted in the North Atlantic, but with lots of lessons for all of us. With that, I'm going to pass it over to Denise and Paul. So please turn your attention to them. Thank you.
Hello, friends. This presentation takes place on Indakina, our homelands, and is the unceded traditional ancestral lands and waterways of the Abenaki, Cayuga, Maliseet, Mi'kmaq, Mohawk, Mohegan, Mahegan, Narragansett, Niantic, Nipmuc, Oneida, Onondaga, Paugussett, Passamaquoddy, Pennacook, Penobscot, Pequot, Shattuck, Seneca, Shinnecock, Tonawanda, Tuscarora, Wampanoag, among many others who are here both past and present. We acknowledge and honor with gratitude the Aki, land, Nebi, water, Awan, air, Olak-Wikak, flora, and Awa'asak, fauna, and for our ancestors, the Alnumbak, human beings, who have stewarded Indakina throughout the generations for over 13,000 years. We would like to invite Chris to read the mission statement.
Thank you. Thanks. There's my mute button. So you're all here to kind of join our kickoff meeting for this Fire and Fire History Working Group. We kind of envision an informal space to explore connections between fire ecology, climate, cultural traditions, and outreach, with the broader goal of shaping the future of fire adapted landscapes. So really the idea here is to create a community of fire practitioners, ecosystem managers, researchers, educators, and really anybody from the public that wants to be involved. We're mainly just trying to build information, build a knowledge base, have a community where we can share information about fire history, covering the last millennium or longer, and have a space where we can discuss emergent tools, data, perspectives to enrich our understanding of Indigenous fire use, fire effects on regional landscapes, and how the last century of altered fire management has and will continue to influence ecological patterns and processes. The goal of this whole idea that we envision kind of starting now and going for as long as we can keep it is to inform fire management through the co-production of research and to support public engagement on the future of fire in a warming world. So we really just kind of want to build this community and build up information about fire and fire history in our region. Next slide, I believe it goes over to Katie, right?
Yeah, That's me. Good morning, everyone. We're really excited that you're all here. And as we plan this, just been in conversation about being blown away of seeing all these registrations come in, and folks really are calling in from all over the country. I think we've got every northeastern state and province covered. And then we thought it would be informative for the folks here to see just what breakout group interests were. But yeah, as Chris said, we want to put people in conversation, and these are not binding interests. This is just to set up the conversation for today. You can stick around for later meetings, you can change your interest, but we just wanted to show what folks that are here today are interested in. And that said, let's see, who's next? I could go back to Paul and Denise. What folks are going to see today is just some short presentations from your planning team and facilitators today to get to know us and know our motivation. And then we'll move into breakout groups for some conversation for about 15-20 minutes. Paul and Denise.
Thank you, Katie. Kwai Nido Bak, and Delawasin Denise Pouliot, Sagama Squaw, Delawasin Paul Pouliot, Sagamo, Kawasak Band, the Pennacook Abenaki people. Niona Ayan Odanaku Nipi. Hello, friends. My name is Denise Pouliot. I'm the head female speaker, and this is Paul Pouliot, head male speaker in chief of the Kawasak Band of the Pennacook Abenaki people. We come to you today from our ancient Pennacook village named Odanaku Nipi, which translates to the village of the narrowing waters, now known as Alton, New Hampshire. As you can see in this map depicts the Abenaki tribal territory here in the New England region. You can see we have quite an extensive territory, which is how we initially became involved in this project.
You can also see that it's quite a diverse ecosystem that we habitated, from the Ice Age on. It's an extremely diverse ecosystem, and it's worth really looking at in depth through history in the lens of fire management.
Next slide, please. So what we initially started us interested in this project is we really want to return the indigenous forest maintenance practices back to the region. So we started to look at where we were burning and why we were burning. And the question that we had left unanswered is, how often do we burn? So we understood that we were burning to, uncover lithic materials, which is what you see on the left. That's actually some fire-treated rock that's in situ on one of the mountains up on Moat. And below is pictures of some indigenous artifacts that we would have been harvesting the stone to create, as well as bowls and other instruments. So we created, the slide on the right shows the fire-scarred trees from the hikes that we were taking up on the mountains. And we were using the fires to create blueberry bushes and other fruit and nut habitats to draw in the wildlife, so we didn't have to go out hunting as often if we could draw them into us. And we were also using the sap that was coming from these trees in the creation of our canoes and watertighting our canoes and other birch bark items for buckets. And so we believe that the cycle was done in the spring. But our question is how far apart were these fires?
The interesting thing is we used the pitch of various pine trees, specifically the red pine that is viewed there. We used to mix it with charcoal, and if you mix it with charcoal, it becomes like a hardenable epoxy. And if you put a little bit of bear grease in it, it becomes more like silicone. So it became a natural sealant for canoes. Baskets and containers made out of birch bark that was sealed with just charcoal in the pitch were totally waterproof, and we were able to heat our foods in these containers as well. And as she said, we were always interested in releasing blueberries and other berry plants that would bring in other flora and fauna in the same area. Most important, we were always trying to cultivate areas where passenger pigeons would be coming to harvest the fruit for their own life. So the burning was always done to maintain these open spaces.
So part of this wider collaboration that extends beyond forestry is Indigenous New Hampshire Collaborative Collective. This is a group that, that we helped co-found with other professors over at the University of New Hampshire to help uplift Indigenous knowledge within research and within history and social issues. And so a lot of the work that we have done here is also in collaboration with INHCC. And I'll put links to the INHCC website in the chat. Next slide. And thank you very much.
Yeah, thank you, Paul and Denise. It's a privilege to follow you. I'm Katie Glover. I'm your next facilitator that will just give a short overview of what I do and my motivation for helping to co-lead this group. I'll first acknowledge that I am calling in today from the homeland of the Penobscot Nation, where issues of water and territorial rights and encroachment on sacred sites are ongoing. And you can see some resources of how the university works in partnership with our tribal neighbors and colleagues to work on those issues of sovereignty. Next slide, please. So my research background is in paleolimnology. Really what drives my curiosity is what causes ecosystems to change states. How do they go to different vegetation structures, and how does climate play a role in that? So I've largely worked on lake records, doing pollen and charcoal analysis, and these are just some quick visuals of what that looks like. Basic idea is that if you can find these closed basin lakes that have been undisturbed and had continuous quiescent disturbance over their histories, it's like pages of a book. You get all of the pollen that was in the environment that's been collected as trees changed, as spring came and trees produced pollen every year. In that top middle picture there, you can see a cartoon of when the landscape burns. Suddenly you've got airborne charcoal and charcoal in the runoff to the lake, and that accumulates as well. So researchers like me then come along and push a tube into all of it and take it home to lab and start to reconstruct the history of what that environment was like over time. And I've probably been on 100 sites all around the continent so far, helping with these records, several in the Midwest, coastal California, Canadian provinces, and then now a few here in Maine. And again, just a few visuals at the bottom of what this looks like. The bottom middle, you can see me with some of these cores in the field. We take them out a meter at a time. And then in the bottom right, you can see off to my right is the split cores. So what these look like once we get them back to lab and then slice them open and look right at the middle where we can see all of these layers and start to do the sampling and start to do the environmental reconstruction. Next slide, please. Again, I'm a very visual person, so just building on that to show, as you look through the sediment core with oldest on the bottom, youngest on the top, these are some of the things that show up in the samples. With some processing, we can see the pollen grains, and they've all got pretty distinctive shapes to them. An expert palynologist can start to see the proportion of which was pine, which was daisy, which were different families of species, and start to get a picture of what the vegetation structure looked like at that time. We get spores, we get charcoal as well. Charcoal is it's really interesting. There are size thresholds that tell you if it's larger grains, probably it came from that immediate region in that basin, and there was a local fire right there on the site. But if they're smaller, we assume those are extra local and they blew in from some fire far away. And then just a few more pictures of what this looks like, working with students to sample cores. And then the pollen processing does involve a lot of pretty nasty acids and chemicals. Interestingly, pollen is one of the most inert organically produced chemicals or compounds on Earth, and it survives hydrofluoric acid, hydrochloric acid, sulfuric acid as well to remove everything until you're left with your vegetation record. Next slide, please. So one of the records I developed is out west. I did my graduate work in California and ended up developing the longest record in Southern California from a Mediterranean biome. And again, speaking of ecosystem state changes, what these records can tell us is that we see this huge change between times when there was closed tree cover, mostly based on pine. So pine is the primary constituent for what you see as tree pollen there for this lake record. Non-arboreal trees, largely that was sagebrush. really important shrub in the West. If you think of the Great Basin landscape or Nevada, for example, that is probably what that sagebrush steppe looks like. And so we see throughout this record, this kind of back and forth between these two different vegetation states. Alongside that, on the right is the charcoal accumulation over time. And you can see it's probably the most active at the time from about maybe 60 to 30,000 years when there is continuous forest cover. And then at the top there, during the last glacial, when the fire regime is really reduced, we see the proportion of tree species does really well. And I tell the public and land managers really two things from records like this. The first is that right now we are in a different climate system or state of change that we really just don't see in the past. You can see it 70,000 years ago, there's this really, apparently this really precipitous drop in the forest cover for this region, but that's actually about 700 years on this time scale. And as I did my graduate work on this record, California was experiencing massive tree mortality in the mountains of the West, really in the space of 10 years. So past records illuminate just like what a different climate regime we are in right now. And it also illuminates what's possible. There's a lot of questions about what these landscapes will look like with all of these dead trees. And if there's another vegetation state that's coming. Shrubification is talked about a lot. And I think what these records show is like what's possible. We have had sagebrush steppe in the past in these environments as a stable vegetation community to adapt to different climates. And then my last slide. So again, I'd say my big motivation for really helping to lead this group, and what drives my work is here in the Northeast, I think we have a real opportunity to kind of get ahead of whatever tipping point might be coming with climate change and with our forests. You can see in the lower left there that we've got all of the states and provinces are mostly over half natural forested area, with Maine being the largest proportion of forested landscape out of all the US states with continuous forest. So looking forward, I know I do some work to think about how I can contribute to this network of core sites here in New England now. But part of the motivation for me for this group and organizing is that we have incredible people power from different agencies here, different expertise that we wanted to put together in conversation and just talk about these issues and talk about how we can start prevention and management of our forests now to get ahead of any fire risk that might be coming with climate change. Right. So that said, I'm going to pass the mic to Chris. You're next.
Yeah, thank you, Katie. And hello again, everybody. My name is Chris Guiterman. I have forestry training from the University of Maine School of Forest Resources, and I did my doctorate at the University of Arizona in the tree ring lab out there. So I'm a specialist in dendrochronology. I currently work as a research scientist as an affiliate with NOAA. I work for the paleoclimate team there, the World Data Service for Paleoclimatology. You can see the map in the upper left corner here. Those are the resources that we manage. These are publicly available data available through NOAA. And we have a team of IT people and data managers that handle all of that, handle new submissions. My job as a researcher is to be a subject matter expert. So I come in from the tree ring side of things mainly. The other stuff I don't know very much about. But tree rings are about half or more of our holdings, so it's relevant. And then I work on aiding in procurement and use and enhancing access to the different resources. And then on the research side, I specialize in mostly fire history. And I'll talk about that in a second. I'll also note that I have the great privilege of working with the White Mountain National Forest here in New Hampshire as a type 2 wildland firefighter. So I get to go out on some prescribed burns and kind of help with the management. So really trying to keep the practical aspect and the research going at the same time. Next slide, please. So again, my research is largely in dendrochronology and mainly in fire history. The map on the left is a recently compiled network of fire history sites across North America. We published this last summer in Ecosphere. Myself, Ellis Margolis, who's with the USGS out in Santa Fe, New Mexico, led the paper along with a huge community of folks, including a bunch of people on the call today, which is fun to see you all. So that was compiling the network, and now we're working toward understanding fire across the network. So really looking at as many different aspects of fire, climate, vegetation, and people that we possibly can throughout this whole network. Next. With the main goal of providing perspective, right? Tree rings really provide a unique perspective on the past and tell us stories about forests and forest processes that we might not otherwise know. And though, at least in this area, we may struggle to reach a pre-colonial time period using just tree rings alone, I think these fire scars have a lot to tell us about how the forests operated in the past that's relevant for now, and may very well be relevant even going further back in time. So meshing the kind of data sets that Katie can gather and others along with the tree rings, I think is going to be a really valuable tool going forward to understand how fire operated on this landscape. Next slide, please. So looking in at the North Atlantic, right? The North Atlantic Fire Scar Network, do we have one yet? Not really. There's a lot of blank in this map. John, can you hit the clicker, please? So I live here, though I work, my offices are out in Boulder, Colorado. I live in Hanover, New Hampshire. So I'm really thinking hard about what's happening in the forests around us. As I said, I trained in Maine, and I'm from New England originally. So there's pretty scant data for this region, and that's something to talk about, to discuss, and should try to develop. Anybody who really knows the region knows that there's 2 dots missing off that map from Vermont that we're working on from some work in the 1980s. But as far as we've seen, some of the work that has been ongoing is finding fire scars around. Just this middle picture here, I was taking my kids for a walk in the woods, not 4 miles from where I live, and found an eastern white pine stump with 8 fire scars. And there were more in that forest too. So, you know, that was a northern hardwood stand. You'd never know that there was fire in there. I couldn't believe it myself, actually. And on the right is more of what we are hoping to find to really build out this network. That's from a new site that we established last fall on the Nature Conservancy lands in North Conway, New Hampshire. So that's a multi-scarred red pine stump, just a remnant out in the forest. So we're working on this stuff and trying to build out the network. And that's definitely one of my goals for this group, and the mission is to build up these fire scars sites so that we can learn more and more about the forest and how they operated in the past. That may be my last, John. So off to you and Lindsay.
Thanks, Chris. Good morning, everyone. My name is Lindsay Rae Silvia. I'm a field technician for the U.S. Forest Service on the Green Mountain and Finger Lakes, based out of Vermont. And my career, I've spent most of my time as a wildland firefighter. First 10 years out west, California and Oregon, and then the last 9 years back east. And when I did come back east, I was able to meet John Neely, and he's served as a mentor over the years, especially with a lens on fire-adapted natural communities. I also have the privilege of working with 2 of our ecologists on the Green Mountain and Finger Lakes National Forest to revitalize the return of fire to some of these landscapes in Vermont area. The photo there on the left is myself and my other coworkers in fire who've been part of returning fire to an oak pine natural community on the Dome that some of you may have attended, the webinar NAPC hosted last fall. And for the most part, you know, I'm excited about this because it's really the need for us as fire practitioners and fuels planning to connect some of the research and data to support future work and find out where to put our eyes to next. And without further ado, John.
Yes, hello everybody. Yeah, my name is John Neely. I work on the White Mountain National Forest, which is in New Hampshire and Maine. And yeah, I'm very, very interested in fire history, fire ecology of this region. And we can move forward with our slides and talk a little bit about what Lindsay and I think about as fire managers and how we can help with getting more information out.
So some of these photos here are based off of the Green Mountain National Forest, where primarily we apply fire, prescribe fire for wildlife habitat and blueberry, low bush blueberry production, as well as some pollinator habitats. So the experience that both John and myself have had over the years, locally and then elsewhere all across North America, has really provided to have a lens of seeing what fire adapted communities might look like just to the naked eye. One of the big obstacles that we've been faced with over the last several years is just the very limited amount of published fire history data in northern New England, you know, those interior places where those northern hardwoods and mixed oaks may be. One of the questions that we've outlined here is that have we lost the window of opportunity to learn from oral histories, right? If we don't have all of this published data, can we connect and find some oral histories, and are those recognized as something that is recognized like as important to the informed future management? So John, off to you.
Yes, thanks, Lindsay. Yeah, the other thing that we're considering is if the potential for collecting good samples is also diminishing. We have, on our forest, we have gone to areas that we're familiar with, that we see a fire history on. A lot of our samples, you know, carpenter ants, other insects and disease are starting to deteriorate samples. There's a lot of non-native pests that some of these fire adapted stands are facing that could change their character. So, you know, the opportunities to actually collect good samples and get information as the years go by, I think these places could be disappearing off our landscape. This slide shows, for folks, I'm sure most folks understand what a fire adapted or a fire scarred tree looks like, but here are some examples from our area. These are red pines. They're a fire adapted species. They hold fire scars, they respond, they need periodic fire. The picture on the left, you can see all that char on the face of the tree. It looks like it could be recent. It looks like it could have been from an escaped campfire, you know, a couple of weeks prior to today. But that char on there is over 100 years old. So a lot of times people will look at these areas and not recognize them for a fire adapted community, or they think that these are from the railroad or logging era, or that it was a one-off type of a fire. But these particular areas can hold a lot of information on the history of our region. The middle photo, you can see behind all the scarred trees, you can see red spruce, other species coming up, and that's what's going to happen. That's what does happen when fire is taken out of the ecosystem. It will revert to a different stand, in some cases spruce and fir, in some cases hemlock, or northern hardwoods or pine. So on our forest, we're trying, and Lindsay and I are trying to generate interest to collect these samples while they're still existing on the landscape. We also focus in on charred stumps, like the one in the top picture. Sometimes these can provide really good information. You can see next to that charred stump what it looked like when we cut that stump, and you can see lobes that are indicating fire scars, fire return intervals. So you can pull some good information from these stumps, or potentially can. Down in the lower left, you can see a partial cross section that we took out of a fire scarred red pine, and that's a way to use dendrochronology to date the fires. We've also started looking at what are called vernal pools, bogs, wetlands that are right within these fire-prone areas to look for those larger macro-sized charcoal particles that Katie mentioned, and also any of the micro charcoal that might have drifted in from farther away. We're hoping to get a really good signal in these fire adapted communities that shows fire going back in a longer period of time than the wood is able to show. And these are just some examples of trees that we have got to know off of the White Mountain and the Green Mountain Finger Lakes that are dated. Some of the things we found interesting, you know, a lot of these fires predate what people think of as the classic wildfire, destructive wildfire period, which is during the logging era and the railroad era. A lot of these fires were dormant season fires, which means they were most likely intentionally set by humans. We don't get a lot of natural fires during the dormant season. Those are more growing season fires.